Hi there, Andrew Jackson, AJ Design Studio. Today I've put together a video on a Les Paul Junior neck and headstock that I've modelled. So this is based on one of my guitars, which is an Orville Les Paul Junior, double cutaway in cherry red. So it's a Japanese made Gibson. I won't go into that story as to why they named them Orville, but anyway, very similar to the Gibson, as you can tell by the headstock shape. So the reason I picked this as an exercise is one of the main reasons is this little blend around the back here, where you have the headstock. You've got the neck going from the neck section, and it blends out into a planar face on the back here, and then also runs up each side here into the side of the headstock. Like with my Les Paul video, this is a question I've seen on the forums now and then, people struggling with this area. Down the heel end as well, another sort of challenging area. Not as challenging as up here though. This is much more challenging. Sort of had a few variations that I might run through as well quickly. So I'll probably just run through the model quickly, just explain a few things. So this guitar's got quite a baseball bat neck profile on it, so it's quite chunky, and it definitely looks chunky on screen as well. So let's turn the perspective off and let's just roll through the model. Okay, first thing I've done is set up side elevation control. This is where most of the dimensions are controlled. So I've got the neck thickness at the nut, I've got the neck thickness at the 12th fret. I have some control dimensions here for the heel. Obviously there's going to be a blend in here. Got our scale length or neck length based on the scale length. Headstock thickness, headstock angle, 14 degrees. So this here is the nut, and I've got 5mm here. You can see that's our fretboard thickness. There's one tricky area, both of my guitars that have got angled headstocks. The headstock, if you lay a straight edge along it, actually runs through past the nut. So there's this funny little triangle here, which sort of I had to do a few funny things when I was modelling to get around that with the blend, but I'll cover that. So we'll just exit that sketch. And then we've got the fretboard plan control, which is just the fretboard width, again at the heel end and then at the nut end. Then we have the neck section at the nut, which I've used the conic section, angle control, and the row value there, and the same for the heel end. So the neck section at the heel there, got the same dimensions, except obviously the neck's thicker there. Okay, and then I've just lofted those together. That's the loft back of the neck. Plane for the headstock front. So the headstock shape control, I basically did a survey of the headstock using calipers and a straight edge. So this is a bit ish. It's close enough. And I've gone straight line here because this is the bottom corner. Obviously there's a blend in here, and the reason I haven't put a spline in there is because I didn't want to attack that area until I got around to modelling it further down the tree. Okay, so then I've extruded that headstock. Then I have added this little funny bit here, which, as I said before, this is the end of the headstock, end of the fretboard, sorry. So if we look from the right, you can see the top of the headstock runs past and then into the fretboard area. I've got a dimension to control that because on my old Gibson Melody Maker, this is actually much further down here, whereas on the Orville it's up here. So okay, so now we're going to start doing the headstock blend. So the first thing we do is I've deleted some of the faces out of that solid, turn it into a surface. And then I have, we'll just bring up our neck surface. On the right hand plane, I've drawn the blend, which is a standard sort of thing I've done. Got a circle control the endpoints of the spline. It's a Bezier curve, degree 5. So it's curvature continuous at each end. Because it's matching onto a line on each end, I've just used collinear constraints instead of using the G2 constraint there, or the curvature continuous constraint, just so I don't have any over definition issues. Okay, I've created a plane at the end of this blend here, as you can see, and then use that to trim back the end of the neck. Okay. Created a plane over this end here, again at the end of our blend section, and then trimmed back these surfaces. Okay, so this is the final way I built this. I'll just roll forward to the surface, which was overbuilding a surface, overbuilding 2 blends, and then trimming them back, and then running a 3rd blend along this junction line or intersection that I was left with. So I can go, I'll skip quickly once I get to the end. I'll go through version 1s through to 6, the different ways I went through to try and achieve this, and this seemed to be the best way to do it. So what I've got is I've got the outer section here, which is a 3D sketch. That's a degree 5 style spline again, so it's got 6 CVs, and then I've got constraints, get the G2 on each end. Then I also have a mid section here, just because I was getting a few continuity issues through the middle here. So we turn zebra stripes on. You can see that it's pretty good across here where it runs into the planar face, and it's okay over here as well. You can see the surface gets a bit ugly over here, but this gets trimmed back, so I'm not too concerned about that. Okay, next phase is to trim this back. So I've got a sketch to trim control there, which is a degree 3 style spline, because it's got 1, 2, 3, 4 CVs, and that is controlled with some angles and dimensions on the control polygon segment. I actually extruded that and used the extrude to trim this face here, because if it's an extrude, it's much easier to use instant 3D, because you can just pick on the extrude there and then you can drag your dimensions around. Okay, whereas if that's a sketch only, you've got to go click on the sketch, and then sometimes if you accidentally double click the sketch, it will enter you into editing the sketch. It's just a bit of a pain, so it's much easier just to get the sketch and then extrude it, and then you can just click on the extrude and drag those dimensions around. Okay, then I've created, because I'm going to create a section on the top plane, so I'm going to make a 4-sided surface in here. So I've created a 3D sketch, which is basically just an extension of this line here, and then that has a coincident to the top plane. As you can see, it's on the top plane at the end of that point. Okay, and I've created a section on the top there, and I decided in the end to overbuild the surface, because otherwise it would be a bit weird if I tried to do this out of patches to an explicit line in here. So that's a resultant line there. So I've kind of had to use my iometer. So if you change this angle here, it's obviously not 55 degrees down here where it actually intersects with the top of the headstock, if that makes sense. So the overbuilt surface is much cleaner. So that's fairly clean. You can see what I mean. I've trimmed back this surface here, so this first blend, all that stuff, the funny stuff along the edge, that's all gone. Okay, next up, I'm going to trim that and trim it twice. So we've trimmed that surface and we've trimmed our headstock top and knitted those together. Now I'm going to run a loft along here, but I want it to be a variable section. So instead of using the sweep pipe function, I had to use the loft. So I've created this loft tool here. Okay, and so there's a plane normal to the end of this curve here, and then another plane normal to the end there, which have the sections on them. And you might have noticed that is an arc. It's not a closed circle. So the reason behind doing that is if that's a circle, then I have to choose where the connector goes in the loft, which means you can get twist going on, and there's no way really to clip that connector onto much. So it's easier just to draw your circle, then draw a couple of construction lines. So if we go into this sketch, a couple of construction lines, and then just use the power trim to to take out that quadrant, and then we're left with this Pac-Man shape, which means when you loft it, there's no worries about connectors, because there's the start of the curve and there's the end, and it's the same on both ends of the section. So this is just it's got two profiles and it's a center line, so I'm using the edge as the center line. Okay, and then that gets extended on each end to make sure it penetrates or overlaps past the ends of these two surfaces here. And then that surface, the loft, is used to trim those out, which leaves us with this hole to fill. And I've added a split line here because I'm actually going to take this blend out to the end. So split line, delete face, and then I've added a section. So instead of drawing a section like on the surface here, which means attacking angle, what would you call it? It's called rotated around. So I figure it's much better to have a plane that's normal to the end of the flow of the surface that we're creating there. Now I've created a section on there. I've got a blend section there. All these blend sections, I'll just show you one of them. I'm not going to go into detail on each of them, but they're pretty standard intersection curve on each side with the faces we're trying to blend between. Degree 5 style spline with a equal curvature constraint on each end. And then I've selected all the control polygon segments. So you go right click, select chain, and then delete two lines there, and then just go equal. So they'll take care of themselves because they're both set back from the same sort of virtual edge that we had there, theoretical edge. So if you change the blend sizes or the variability of this cutout, these blend sections will update. And I've got a number of those blend sections in there. As you can see, I've got 1, 2, 3, 4, and then a boundary surface blend with tangent face on each of the longer edges there. And because we've got so many sections, I turned the tangent influence on those down to 0, because if you turn it up, you get some funny wiggles going on up this end. Okay. So that's that blend. Then I've extended it, 3D sketch intersection between these faces, and use that 3D sketch to trim those and knit things together. So we have a look at that blend there. Quite happy with the result overall. So yeah, quite a tricky area because you're going from like a full round through to a planar face with the corner in it. So definitely a bit of fiddling with some of the dimensions. And then the fretboard top surface, which on the nut end, there's my fretboard radius, 12 inches. And then down the heel end, I've got another sketch with the same thing. It's set as coincident to the edge of my neck here. And then I've created an extrusion direction because I want to have a constant radius up the fretboard and I want to extrude that like so. Then I need a slightly different extrusion direction. So that radius here, it's slightly higher on this end than on the nut ends because the fretboard is wider, and because this is horizontal along this edge here, that means that the arc is slightly higher in the middle there. So that's the extrusion direction. Okay, and then I've got extruded fretboard, and then I've extended it out so I can trim all that together and knit it. Okay, one thing I didn't mention is I've baselined all the dimensions on this around the origin being in front of the nut, so the 0 fret basically, and then at the outside edge of the fretboard rather than the radius center height of the fretboard. Okay, it's probably easier if you're trying to set up necks for, you know, for scale lengths or bridge positions and stuff. Okay, next up is the heel. So I've got the heel center section, which is a curved continuous on this end, and on the other end I have an angle like that. And then I've created a plane through the end of the heel there, use that to split the underside of the neck. Then I've created a plane which is like the heel cap, or so that's the heel plane control, the form there, and create a planar surface there. We've got the heel outer section, so I'm going to make a four-sided surface in here as the main blend. And again, this heel outer section is much like the inner section, and then I've got a mid section as well. So I've got 1, 2, 3 curves in one direction and just the 2 edges in the second direction. So there's our heel surface. So again, I sort of played around with those sketches there using Instant 3D. That's why some of the dimensions are a bit messy. I was form finding. I wasn't too concerned about having nice rounded numbers. Okay, then I've created a planar surface on the outside here, the side surface of the heel. And then to blend in between these two surfaces, I've created a pipe sweep. So if you haven't used these before, so you select circular profile, and then you pick your path, and then you can just change the diameter rather than having to sketch a circle as the sketch profile. Okay, and then I've extended each end of that, and then use that to trim out these faces, leaving us with a four-sided hole. Actually, five-sided. Right. Okay. Now I've created an axis here. What I'm gonna do is do two blends in here. So a bigger patch and then this funny little one here, and it's kind of critical we end up with a section here being curvature continuous to this surface here. This surface here is planar, so that means I can actually add an axis here. Hope this makes sense. Add that axis in there. Instead of extending the surface out here, so I could put an intersection curve through it, because I know this is planar, and I put an axis normal to that surface at this point. That means I can make my first two, this curvature is going down to 0 because it's going down to match a planar face or a line. So these two sketch segments are collinear, but then one of them is perpendicular to our axis. Okay, so that means that end is a curvature continuous connection to the planar face. Hope that makes sense. Okay, and then I've got a section on the second end, built very much the same as all the other blend sections. Trimmed this end back and created a loft. I got a better, cleaner result with a loft than I did with a boundary blend. So that's nice. Okay, and then I've got to create this little patch here, which I was a little bit worried about because sometimes I want to use this edge explicitly and I didn't want to have a wobble, but it turned out okay. So to build that, I added just another section in the middle here with the same angle as I've used to control the neck. So the neck is 88 degrees under here, the neck section, so I've just matched that with my midsection on that surface and knitted that together. So that flows quite nicely down, round and into the heel, especially because the heels are quite a different shape to the neck section. Right, and then I've solidified this. So to solidify it, just created a couple of planar surfaces on the end of the heel there, and then one along our center line. Knitted those together, and then used insert boss base thicken to thicken it into a solid by create solid from enclosed volume. Right, next up I've just added some splits and fillets. So I've cut out the slot for the nut, trimmed off the nut, added a radius to the top, and then started adding some fillets to the product. Couldn't add one here in the middle of the moustache until the part's mirrored, so just wait until then. Added a few split features to split out the fretboard and to split out the laminate on top of the headstock. And then added a few more fillets and mirrored everything over and added a body delete at the end to clean up the surfaces. Okay, so there you go. And of course, this happens quite often when you have an appearance and then you mirror something. So copy appearance, then we'll right click on this and click tangency, kill all the appearances for the faces, and it's back. Okay, so that's the Les Paul Jr. neck. Right, I'm just going to run super quickly through my alternatives here for the blend, seeing that was by far the biggest or most difficult part of this model. Okay, first version was trying to extrude that central blend, extrude it out and then trim it back like into a point like that, because there is quite a defined, you can feel it on the back of the neck where the blend goes from the neck up to the corner of the headstock. But then I just couldn't get the surface here to work, and I was kind of getting this awful tuck kind of thing going on there. So that's why I came that idea, and we went on to version 3. Okay, version 3 was, instead of extruding that surface in the middle there first, I decided to give it some breathing space and take this point out. So I made an actual blend there instead. So I blend like that, and then added the second surface on and trimmed everything up. But again, with this, it was a bit fussy to control, and again, it was kind of, because you've got this surface curving and tucking under in conjunction with this face here, which is receding, you get quite this illusion of a big tuck under there. And it was just a pain to control, to be honest. And I couldn't get as nice a blend as I wanted. Okay, so I went on to version 4. I think version 4 is the first version of our, oh no, it's not the first version, sorry. This is the last one before I changed how I was going to do it. So I had this control here, again 2 surfaces, but I overbuilt up above here, as you can see, rather than trying to build to an explicit line on top of the headstock. So yeah, it's just lots of playing around with this control here with the zebras on, but I just couldn't get rid of this. There's the funny ridge along here, so that's when I decided to go with my final way, which was to build a full size overbuilt surface here and then trim it back, which was a good idea. Anyway, I'm going to wrap up there. This is a long video. If anybody wants this file, I will stick it in the description. You can download it and pick it apart. Yeah, so I might do a few more guitar related things because it's an interest of mine, and I'm thinking of gearing up to try and do a few of my own guitar projects. Anyway, thanks for watching. Andrew Jackson, AJ Design Studio. Have a good one. Bye.